Rationalize the denominator. In the first problem, we have 12 over the fourth root of 4b. In the second problem, we have 6 over the square root of 10 plus the square root of 2. In the first problem, we just have one radical, or one term, in the denominator. So the first thing I'll do is I'll rewrite that as factored. So it'll become 4 will be 2 squared, and then we still have a b. My goal when there's only one term in the denominator is to give it what it's missing until I can create the smallest perfect fourth. So since I already have two 2's, then it needs 2 more 2's. And since I only have one b in the denominator under the radical, then I need 3 more b's to create the smallest set of 4. So I'll have 2 to the fourth and b to the fourth underneath the radical on the bottom. So whatever I multiply the bottom by, I also have to multiply the top, or the numerator, by. This way I'm still multiplying by 1 and I get an equivalent fraction. So this gives me 12 times the fourth root, and I'll go ahead and simplify 2 squared to be 4, and then we have b cubed in the numerator. Now the denominator, remember I created the smallest set of 4 that I could, so I had 2 to the fourth, b to the fourth, all under a fourth root. So that just became 2b. Finally, we can see that 12 and 2 can divide out to give me a 6 in the numerator. So I'll have 6 times the fourth root of 4b cubed, and in the denominator I just have b. Now in problem 2, we have 2 terms in the denominator, and it doesn't matter if only one of them or both of them are radicals. But the only way then to get rid of all the radicals in the denominator is to multiply by the conjugate of radical 10 plus radical 2. So I'll go ahead and use radical 10 minus radical 2 in the numerator and the denominator. So I'm still multiplying by some form of the number 1. Now, rather than distribute the 6 in the numerator, I'd like to see what the denominator becomes first, to see if I can factor anything out and simplify. So I left the 6 outside of my radical 10 minus radical 2 in the numerator, and then foiling out the denominator, again, these are conjugates on purpose. So I'll get square root of 10 times square root of 10 is just 10, and then the outsides and the insides cancel, and then radical 2 times radical 2 is just 2. So I have 10 minus 2 in the denominator. So once again, leaving the 6 on the outside, I'll have radical 10 minus radical 2, and then the denominator is just 8. So we can see that 6 and 8 have a 2 in common. So I need to simplify those out. Now I'll go ahead and distribute the 3 in the numerator, giving me 3 radical 10 minus 3 radical 2 all over 4.